Okay, this is a video about my process of investigating an old valve radio that I bought. I bought this valve radio at a boat sale just a few days ago, and it was made in what I can make out about 1952, and it's a valve radio uh, made by Vidor, who I think are battery manufacturers. I've managed to get some information on it. Got this service sheet here. Apparently referred to as the Lady Margaret. Whether that means it was intended for ladies, I don't know. But there's the radio there, and like I say, it's a valve radio. And if we look at the circuit diagram here, we can see there's a valve here, valve here, valve here, and a valve here. Now, I don't know a great deal about valves, and although I did study radios back in the day, I've got to admit I'm a little bit rusty on the old subject. As far as I make out, you've got a valve here which has got an arrow going through it, which again would suggest it's tunable. I don't know. Tunable again? I don't know. And then two more over here. I can only think that this is some sort of oscillator circuit. I think if I can remember what's it called again? I don't know. Super heterodyne. Okay, so let's go through what it says here. The first valve is, hang on, where are we at? Okay, so let's go through what it says here about it. The first valve is a heptode valve, which operates as a frequency changer with electron coupling, whatever that means. So that's basically it there. So it's basically being used to tune the system, which, as far as I'm aware, will then give you an intermediate frequency here, which according to the instructions is 470 kilohertz. This valve, as far as I'm aware, then amplifies the intermediate frequency. I'm going to have to assume that the next valve in the circuit is used as what they refer to as a detector. Is that correct? Audio frequency component is in rectified output is developed across capacitance, blah, 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 oh, it talks about automatic gain control, so must be some sort of feedback in here. But anyway, I'm assuming that this is basically the detector thing that converts the AM into audio, and then this here will be the final output valve which drives the speaker, and that's so you can actually, it's loud enough to listen to. Now these valves here, from I can understand, are referred to as pentodes because they've got a cathode, 1, 2, 3 grids, and then anodes, so there's 5. But the magic one, this heptode, is going to have 6 of these little blighters in it. Oops, lost focus. Come on. Is going to have 6 of them in. So I'm even more lost as to what they do. Okay, so here's my little my understanding of how valves work. Now this might be completely incorrect, but here we go. My understanding that a valve works as follows: you have a glass tube in which the all the air is pumped out and evacuated to such a point that there's a perfect vacuum in here. And Americans refer to them as vacuum tubes, I believe. And in this vacuum tube, there's then a heater, right, which is fair enough. And then there's a bit of metal either connected to the heater or I don't know, and that's your cathode. Okay, and then at the top, or at the other end anyway, there's another connection called the anode. And my understanding is that if you connect negative voltage to the cathode, and because this cathode is heated up to such a hot extent, and because of the material it's made of, which is quite exotic if memory serves me right, the electrons that are in this wire actually, rather than just staying on the wire, actually start to float off, and you get the little electrons just floating around. Now that's not particularly exciting, but what is exciting is if you then put a positive charge on the other end, what then happens is that these electrons, much the same way as iron filings would be attracted to a magnet, and because there's a vacuum in here, there's nothing to prevent them moving, there's no air molecules, no gas molecules or anything, it's a perfect vacuum, will jump up and combine with the anode and then continue on their circuit, continue on their merry way. So if you have a battery sat in there, negative at this end, positive at this end, the electrons will loosen themselves from the metal plate, travel across the vacuum, collect, and go around the circuit. And that is all very exciting. But the effect is useless, really, because, I mean, you could just put a piece of wire across here and you get exactly the same effect. I mean, the fact that these electrons are jumping across the vacuum of space, although interesting, is not very useful. What is useful, however, is that if you turn this battery round, so now you have negative at this end and positive at this end, what of course happens now is that there isn't any electrons to loosen off here. The electrons are all at this end, and of course, because this is not heated, and because it's not made that special material that I can't remember the name of, it means that the electricity flow will not go this way. So in other words, when electric's going negative positive, you get current. When you go negative to positive, no current. And this is basically what a diode is, or a rectifier, whatever you want to call it. It's a way of making power go in one direction, and that's quite useful for rectifying AC, for example. So that's a diode, right? But this machine, this radio I've got here, doesn't have a diode in it, but as far as I'm aware, it works on roughly the same principle, in that you have your glass valve, you have a heater, you have negatively charged cathode, and you have an anode which is connected to positive. So that in itself is just the same. Okay. And if you apply electrons this end, they will jump across here and will go around. However, what you can do is you can put a grid in between. Now, they say a grid. I assume it's like a mesh. Right. If you connect this to a more negative source than your cathode, rather than the electrons going all the way around, it basically acts like a brake, and the electrons just sort of like sit around here and they don't go any further. So essentially, by applying a negative voltage here, you can control the valve just like a switch, which again is okay, but you know, you can make a switch in other different ways. What gets exciting, is my understanding of it, is that when you get into the spot between where it's fully on and fully off, by varying the voltage on this grid in a small amount and with very little power, you can have a massive effect on the power that goes through the anode. And this turning a small change into a large change is an amplification. So therefore, you've just created an amplifier. And amplifiers have lots of different uses in electronics, as indeed does electronic switches. But in this particular case, when we're talking about analog electronics, as in this radio I'm trying to fix up, that's how it works. Now, what I have discovered just by a little bit of reading earlier today is that this is as far as I'm aware, it's called triode, I think, because it's got 3 connections. But the valves that are in this are pentode because there's more grids. There's a grid there, so well, and a grid there, and as far as I'm aware, one of them, which I think is called the screen, is used, and for some reason it reduces the capacitance across the valve, or eliminates the capacitance even, so that it doesn't act as a possible source of oscillation. I believe that's how it works. And then the final thing at the top has a name which now escapes me, but it somehow shields the screen and everything from loose electrons in the valve or something, and again it has the effect of reducing oscillation within the valve. But basically, the really exciting ones are the cathode, where you provide the voltage in, the anode, where you take the voltage out, and this grid, where you can control the flow of the electrons using a very small input signal. And like I say, you've got to remember that this here is a vacuum. Right. Oh, and I forgot to mention, I think that this heater down here, that also needs voltage as well. You've got to heat this wire up to a very high temperature in order to release these electrons. The heater, the voltage and the current that you're supplying here actually has no further effect on the operation of the valve. It's all taken care of by this completely separate circuit here, but without this heat source, the valve doesn't work. So where does that get us? Well, this is the radio that I'm going to try and get working. Like I say, it's the Vidor Lady Margaret battery portable radio CN429. And if I open this door, we can see the innards of the beastie. Okay, so what have we got here? Well, we've got the speaker, which is the output. We've got the output transformer, and if we go into our circuit here, so there's the transformer there, and there's the speaker. As far as I'm aware, what this does is it converts the high voltage, low current output of the valve to low voltage, high current that you need to drive the speaker. I believe that's how it works. Okay, so that's there and that's there. That transformer is driven by, I assume, one of these two pentode valves here. Okay, the other one being what I believe to be the detector valve, which means that this one is the intermediate frequency amplifier, and this is the oscillator that does all the fancy frequency nonsense. And then up here you've got an air capacitor, and if you alter the tuning, you can see that what you're doing is you're actually putting plates in between plates, and therefore creating a capacitance with air, and that has the effect of altering the tuning which allows you to select the correct radio frequency that you want to listen to. Okay, there's very little else in here. There's a volume control. There's a switch for changing between medium wave and long wave. And that's it. Now in the bottom here, there's two battery connectors. There's a 2-pin one, and oh, my wire's broken off, didn't realise that. There's a 2-pin one and there's a 3-pin one. Now my understanding is that the 2-pin one is a low tension battery, which is 1.5 volts. And all that 1.5 volt battery does is it runs the heaters in the valves. So the 4 valves got heaters in. When you switch them on, they'll light up glowing red, and that's what that 1.5 volts is for. The rest of the radio runs on what they refer to as the high tension battery, which is, believe it or not, 90 volts. There it is, it says there, a 90 volt battery. And that's one of the things about valve radios, that in order to encourage these electrons to jump across the vacuum of space in the way that we need to, it does require quite a lot of voltage. So this little radio required a 90 volt battery in order to get these valves to do what they need to do. And as a result, all of everything in here, for example, look at this capacitor here, this one's rated at 200 volts. So basically there's quite a lot of voltage flying around inside this thing. All right. Okay. So where does that get us? Well, I suppose the first thing to check would be to check to see if, at the very least, the heaters are running in the valves. That'll give us a good idea. That'll give us a starting point at the very least, won't it, as to whether anything in here is worth salvaging. I don't know. What I'm tempted to do is to remove the valves one by one, and then to put them back individually. I think that might be possible. You see, I don't know whether to... Oh, it's a tricky one. It's a tricky one. Is it worth taking the risk on? I don't know. I'll tell you what, let's just put 1.5 volts on, and let's just see what happens there. Yeah, what the hell. Okay, so I've decided to be brave and have a go at seeing what I can do here. I'll say brave. I'm only going to test the low current side today, the low tension side today, which will put the heaters on, hopefully, on these valves. The valves that will cause the fireworks, the test that will cause the fireworks is when I put the high tension side on. But I'm not going to do that today. Right, so here we go. So positive goes to that pin and negative goes to that pin. So I'm just going to flash it for a second, see if I've got current. Well, I've got to be honest with you, I would have expected something more to be happening. I mean, there's not a flicker of life there, is there? Not a thing. Right, okay. Time to put a meter on it. Okay, so let's try the continuity test to start off with. So between there and there, oops, come on. Between there and there, we have 6 ohms. which for me sounds about right. Okay. Maybe we should change it to current now. Try on current instead. Okay, and we have some current being pulled. It's in the milliamp range though. That's alright, is it? It is meant to run off batteries, I suppose, so maybe it does run colder than your average valve set. Well, that one was definitely loose. That's the current has gone up since I moved that one. So there we are at 108 milliamps. So if I move this one there, no, let's get it back again. There we are, 108. So that one's definitely in circuit. That one I know is in circuit. That one's in circuit. Right, they should all be in circuit. All four of those valves is drawing a proportion of the current. So we definitely have filaments. So it looks like we've got 4 working filaments. So even though I can't see any indication whatsoever or indeed feel any heat buildup whatsoever. Okay, I'm prepared to believe right now that those valves are pulling low tension. So now is the time when I have to get more braver and think about putting high tension voltage through this thing. Now the issues could be any one of these capacitors could be dry, short circuit, without me pulling all of them apart and having a good look. Well, regardless, I don't have a 90 volt supply at the moment. A 90 volt battery. The battery I would need to have gotten was an L5512, and as far as I can make out, they're not available to purchase. I have toyed with the idea of buying 10 9 volt PP3s and seeing if put them in series. That would give us 90 volts. Or I could go out and buy a power supply that will give me 90 volts. I won't know what I'll try, will I? So that's going to be for the next installment of this video. I'll get some means of voltage. We'll whack it across. First of all, without the heaters running, so at least no current will be going through the valves. And if that's successful, we'll try and bring the try and heat the valves up and get some current flowing through it properly. But until then, there we are. The Vidor radio. I mean, it is quite straightforward. I mean, as far as I make out, this is the aerial, which sits behind this panel. That's what that wires is for. You've got a volume control, which is fair enough. You've got a switch between medium wave and long wave. There we go. Tuning dial, which as you saw was connected to that air capacitor thingy-majig. And then there's an on-off switch, and the on-off switch is worked by this arm here, so that when you push the lid down, it turns the power off. Right, time to buy a battery or a power supply. Right, until part 2.